Okay, this is the main manual control panel for the machine. Lives between the injection side and the mould clamp side, and basically there's a key switch in the middle which sets some different operating modes. There's a host processor mode, a dry cycling mode, and the main automatic cycling mode here, which you generally leave it on. There's obviously an emergency stop for things which go terribly wrong. You thump that. This switches between manual and automatic, and this is your start stop reset button. So it's fairly straightforward. And then down here on the key panel we've got motor on and off, heaters on and off, and then these are the actual movement controls, mould open, mould close. This is the barrel assembly forwards and backwards. This is the screw inside the barrel forwards and backwards. This is actually the inject button, so you hold that down to squirt the plastic out. Ejectors forwards and back, which I don't use on the moulds I use. Conveyor belt on off, an air blast, which I don't use, but there is a facility for putting an air blast on here to blow parts out of the mould. This is the dosing button. You hold that down to load the plastic, and then there's a 0 button here, which is used in combination with some of these others to set the 0 point. So you would push the nozzle all the way forwards and hold that down and push 0, and that sets the 0 point for the nozzle. Likewise for the mould, close the mould fully, hold it down and push 0, that sets the 0 point for when the mould is shut. And likewise for the ejectors, you hold the ejectors all the way back and press the 0. So these you only need to set once you program the machine in the first place, but this is basically how you control the machine in manual mode, opening and closing, injecting, dosing and so on. When it comes to programming the machine, there is a dialogic control panel here, and this is basically some miscellaneous settings over here for the conveyor belt, the heating system, what state the valves are in. This is just your process settings in terms of how many you've moulded. You can tell the machine to shut off once it gets to a certain number. Set features, so you can save your programs, various alarm settings and so on. This is all kind of miscellaneous stuff. The main automatic programs are all set over here, and you've got very similar symbols. So we've got mould opening and closing settings, the main barrel assembly settings, dosing, injecting, holding pressure settings, ejector settings, various times, temperatures, machine settings, and the keypad to enter them all in. This is actually running on an old 8086 processor, which shows its age, but I think this is one of the first digital machines that came out, certainly from Arburg. Prior to the late 80s, certainly late 70s, early 80s, most of the machines tended to be analog systems where you were setting various dials and knobs to control the pressures and temperatures and everything, but the digital interface makes things a lot easier. Unfortunately, the screen has gone on this, and they're a nightmare to find replacements because they're really weird scan frequencies. So there's a conversion box on the back of this which basically allows me to hook it up to an old PC monitor. And when you first switch the machine on, it goes through various tests and gives you a system operative, and then you simply hit the start button and we're into the machine to set all of the various parameters. The operating data setting data screen is where you tell it what your screw diameter is, how many mould cavities you're using, and then these 0 point settings here, which you can type in initially, but you ultimately override these by using the manual controls to just close the mould and 0 point on the nozzle and so on, and hold down that 0 key. You don't set all of these parameters. Some of these do require an actual number to be added. For example, the number of cavities, you can't have that set to 0. It has to be set between 1 and 99, but I generally just set it to 1 because then the machine counts how many cycles you've done. But obviously if you're running a multi-cavity mould, you type that number in there, and then your machine setting page will tell you how many parts you've made and how long it's going to take to mould the rest of them. One of the first pages that you need to set serious parameters upon are the dosage and also the decompression, but the dosage comes in 2 stages and it's done by circumference speed, so it's not a particularly intuitive value. But as you can see down here, it goes between 1 and 25. Generally, if you're running a fairly soft plastic, you want these fairly low to avoid overheating it, because the faster you spin the screw, the more heat you're going to put into the system. And generally you would have a fairly fast speed to begin with, and then slow it down when you get to a certain point. The amount of material you're actually injecting is down here, the 9 cubic centimetres at end of dosage, and I've set here second speed on at 7 cubic centimetres. So basically it will dose at 10 for the first 7 cubic centimetres and then slow down to 5 for doing the last 2, and that just gives you a slightly more accurate dose on the system. It does go down to 0.1 cubic centimetres, which is roughly 0.1 grams, but plastics have slightly different densities, which is why they work in cubic centimetres. And then another setting down here, dosage monitoring, you need to set that one because that's essentially the timeout. If it hasn't reached 9 cubic centimetres within 9 seconds, then there's a problem. Usually you've run out of plastic and the machine will flag an error and shut off at that point. The back pressure, sometimes you use, it depends on the plastic, and that's just applying some pressure to the screw, so as it's dosing and trying to move backwards, it's got a bit of a force pushing against it, so that tends to give you slightly better packing of the material that you're going to inject, and it can also be used to put a bit more heat into the system. And again, you've got 2 stages of back pressure and a swap over value here, but these aren't too critical, and there's also a dosage delay should you need to program that in, but generally speaking that's not too critical. Now the decompression is kind of the opposite to the back pressure. Basically either before or after you do the dosing you can retract the screw slightly to just take the pressure out of the system, and generally I have a couple of cubic centimetres here. It depends on what material I'm using, but it can just stop the material from dribbling out because otherwise everything is pressurised in the system. So this is just a pressure relief kind of setting, and then a couple of other miscellaneous things down at the bottom. Back pressure off in manual mode, so it just saves you coming in here and switching them to 0 if you need to turn the back pressure off. Once you've dosed your plastic, you need to inject it, and you have 5 different stages on the injection. So if we've got 9 cubic centimetres, we can tell it how fast in theory we want that to go in. Generally you want this sort of like 45-ish, and you don't need to set all of these, or you can set them all the same. So I might go say 45 to begin with and then 25 and ignore the rest. And then you've got the injection pressure, which is actually the pressure limit, so the machine operates by trying to maintain these speeds, and it will go up to whatever pressure I program here. And if it hits the pressure limit, then obviously it's not going to inject at the speed you set. It will slow down and do the best it can, but it's not actually injecting at that pressure. It may well not need anything like that to be able to inject at the speed you've set. So that's a limit rather than the actual injection pressure that the machine will be using, although it might go up that high if it's struggling to fill the mould. And then down here we have the changeover flow speeds. So if I'm injecting at 45 cubic centimetres and I've got 9 cubic centimetres in the system, I might want it to slow down, say when it gets down to 3 cubic centimetres. So it would do the first 6 at 45 and the last 3 at 25, and obviously you've got 5 stages here. And then just like we have a dosage monitoring setting, we also have an injection monitoring setting, and what you set that to is not hugely important, but by setting it to 6, basically if it doesn't inject 6 cubic centimetres then there's something wrong, and so again the machine will stop and time out. You can have an injection delay here, just like you have a dosage delay. I generally might set that to a second, just so that the machine's not running as fast as it could do. It just slows it down slightly. And again you have injection monitoring in terms of time, and if I set that to say 9 seconds, then basically if it hasn't injected in 9 seconds then there's a problem, and again it will flag an error. There's a few other controls here which you don't generally need, but what is important is this switch over to holding pressure, which you can either do on a volume basis, a time basis, or you can do it with a fairly fancy monitoring system. But a lot of people will use the volume controlled, so you might get down to the last 1 cubic centimetre and then switch over to the holding, or you can just go over time controlled, which is what I tend to use, say 3 seconds, so it will inject and hold at that injection pressure for 3 seconds before it switches over to the holding cycle. And if you thought there were a lot of stages on the injection for quite a small machine, well, there's 10 stages on the holding pressure. Again, you set the flow, and this isn't too critical, but because generally you switch to holding pressure when you're down to the limits of, you've only got a little bit of plastic left to inject, so this isn't enormously critical. But the holding pressure, this time it really is done on the pressure, so you might go something like, dropping it down in stages like that. And then all of these are a little bit awkward because they have to be set to 25. It won't run on 0 bar, So that's all those set, and then over this side there's a little setting for the time it takes to switch over to the holding pressure. Anything up to a second it allows, so half a second, it's not too critical. And then you've got the holding pressure times. So if I program a few values in here, basically what this is going to do is after it's injected and got to that switch over, after 3 seconds or after a certain volume, it will switch to doing a holding cycle where it holds the plastic in at 1500, then 1000, then 500, then 250, or whatever you want to set, as many stages as you need, and it will hold those pressures for the times you put in here. So this gives you a way of packing the material in the mould, and really this is serious overkill for a machine this size, but this is one of the reasons why I like Arburg systems, because they do give you this level of control. Generally in industry, if a mould doesn't work on one particular machine, the factory will just swap it into a different machine and see if it runs in that. But if you've only got the one machine, then you don't have that option. So having a machine which has an enormous amount of control settings just gives you a little bit more versatility and a better chance of actually getting the mould to run. Now up here, these settings are material cushion, and that's basically leaving a little bit of plastic in front of the nozzle so that you're not driving the nozzle all the way there. So again, this can tie in with doing the switch over at a certain volume of plastic left, and you've got the amount of material you want to leave at the front. Spelled badly, this is translated from German, and a tolerance on that. So I don't tend to use these very much, but some moulders do. Now the other setting that's related to the injection side is the nozzle itself, which is the whole heated barrel assembly, and that can move back and forwards. Generally, sometimes you do retract the whole barrel after every shot, sometimes you just leave it connected permanently. And those settings are down here. Do you want to retract the nozzle before your dosage and decompression, or afterwards? And if you set these both to no, then the nozzle assembly will stay connected to the mould, and all the action is actually taking place with the screw. But when you do need to move the nozzle around, again you've got 2 stages of movement, both forwards and backwards, and you've got a switch over position here and a tolerance on that position. And then these are quite important. These are the actual contact forces when the nozzle does connect to the mould. It starts on 25 kilonewtons, which is about 2.5 tons, I think, and then it goes up to 5.5 tons, and that's the actual pressure of the nozzle connecting with the mould, advanced delays, and the time for that nozzle force to change over. Shut off nozzle is just not too critical. There are different ways of doing this depending on different settings, but if you just do a shut off nozzle at injection start, that sorts the problem out. So you do have to have one of those programmed, but it's not an important setting. And then the retract speeds, again, you can set to whatever you want. So just set all of those to 50, and a retract delay if necessary, but I'm not actually retracting the barrel, so this is really more for manually moving the barrel in and out. So this isn't a hugely important screen, but you do have to type in quite a lot of these values, otherwise the machine won't run. The other key parameter for the barrel assembly are the temperatures, and these are obviously set according to whatever material you're using. And this machine, as you can see here, it's got 6 heaters on it, and basically the one at the back is the feed, and then we get 4 quite high power heaters. I think actually these 4 are the high power heaters, but generally you have a slightly lower temperature at the front, and then this is the nozzle where the plastic actually comes out. So you set these to whatever are necessary for the material that you're running, and then you have a tolerance setting here for them as well, and basically this will flag an error if the temperatures get above or below these settings. So there's nothing terribly complicated going on here. It is literally material specific temperatures and a tolerance that you want to press, that you want to set, and it will show you the actual temperature and the cycles that are happening according to the pulse width modulation. So if I turn that on, you can see how these are going up. Turn that off because I'm not actually running the machine at the moment. So these are the actual temperatures it's reading from the thermocouples, and it's obviously a pulse width modulated, it's basically a PID system which is controlling all of these. So that's fairly straightforward stuff. The other key settings are mould closing and mould opening, and again we have multiple stages here. You don't necessarily need all of these. I tend to set them quite slow. As you can see Down here it can go up to 800 millimeters per second, which is crazy fast. So I tend to set all of these quite low. And then you've got a closing force, which in this case is a few tons maximum, and a mould protection force. And this basically, if there's anything jammed in the mould when it closes, if it exceeds this pressure, this force needed to close the mould, then it knows there's something jammed there. So you can set this to whatever you want, 5 kilonewtons, half a ton of pressure. And then you get the clamping force, first clamping force and the second clamping force, and this will go up to 40 tons. Generally you set this fairly low to begin with and ramp it up if necessary, so that would be 25 tons on the clamp. And then over here there is a setting for the clamping force changeover. So mould protection double action, we need to set that to yes, and open on alarm yes. Basically that means that if there's a mould protection issue because there's something caught in the mould, it will detect that, it will then try it again to see if it's dislodged the fault. That's what the mould protection double action does, and if it can't, then it will open the mould fully and flag an error. So that's a kind of fail-safe system. The rest of these settings I don't use. Mould protection monitoring, say 1 second, that's how long it holds to see if there's anything in the way, and then it will retract and try it again and hold for a second, and then it will open if there's still a problem. If it's able to get all the way there, then you can tell it to switch the clamping force on after a certain period of time, and then these are the speed settings at which point it changes over. So I tend to set these to fairly random values, but there may be situations where you need to speed up or slow down the mould opening and closing. Mould protection, let's say 2 millimeters there, so if there's anything 2 millimeters wide trapped in the mould, it will detect it. Clamping force on, let's say at 1 millimeter, and then a 0 point tolerance for the clamping. So there's a lot of settings here, and there's also this thing down here which is closing with intermediate stop, and this will basically close the mould to a certain point, then pause for a certain period of time, and then carry on. And again you can set the stop position, the plus or minus tolerance on that stop position, and the period for which it's going to hold at that point. So there are situations where you've got robots coming in and putting things into the mould or taking things out of the mould, so this intermittent stop comes in quite useful on those occasions. And the complement to the mould closing is the mould opening. There is an increased opening force, because obviously when you're trying to open the mould, you've got the plastic moulding in the mould, and that basically glues the two plates together, so you sometimes need quite a bit of force to actually open the mould. I don't tend to use that setting. And then we've got speed settings here, 3 stages, so again I tend to run it quite slowly rather than at full speed. This is the increased opening force, which has a minimum of 2.5 tons and goes up to 10 tons on the opening, and that's your standard opening force, which I set to a ton because it's not too critical. Light barrier and photo cell, these are options for having sensors in your system, so it can monitor those if there's an issue. And you've got the distance that it will open with, the increased force if you're using it, and then the speed settings here for when it will change over to these speeds if you're using them, and then finally your mould open, which is the maximum distance the mould will open, and in this case it will go up to 150 millimeters. That depends on the size of the mould that you're running, and again you've got a tolerance for that which isn't too critical. And just like we had an intermittent stop and halt on the mould closing, you've got the same facility on the mould opening, so that allows you to get robots in and take things out and stuff like that. So it's a very versatile system. Now when it comes to getting your parts out, the general way of doing it is to use an ejector pin system, which will basically fire pins through the back of the mould to knock the parts out. I don't actually use that because I extract all of my items manually, but some of these settings do have a minimum value. You can't leave these at 0, so number of strokes on the ejector, I just set that to 1, and then you've got the speeds again on the ejector. You've got 2 stages of speeds, you've got 2 stages of forces, you've got the point at which the forces change, you've got the position at which the ejectors are fully advanced, the tolerances on that as well. Because I don't use these advanced delays, intermittent stop and halt again, I don't actually use the ejector system, so these are slightly irrelevant to me, but there are an awful lot of creative things you can do, and that one there I need to set to some value, but the ones that I've set are necessary because the machine won't run properly if they're not set. Some of these parameters you can just leave at 0, but there are a few I have to type in to get the thing to run. So this page isn't too critical for what I do, but in an industrial setting, obviously how you eject the parts out is quite important, because you don't want to go too fast because that can damage the parts, and you don't want to go too slow or with too little force because then you might not get them out. So you play around with these until it's working the way you want. Okay, a couple of other screens that I don't use. Core pull. This is all deactivated because I'm not using a mould with the core pull settings. Times, there are actually quite a lot of time settings in the system, but these are all duplicates from what have already been entered in other screens, but this just gives you a one-stop shop to get in and actually change some of these parameters. And the two that you do need to add here are the cycle time monitoring and the idle time monitoring, and this is basically another timeout setting, so that when you're opening the mould, extracting your parts and so on a manual system, if it exceeds either of these two values, then the machine will basically flag an error. So I set these fairly high to give me plenty of time to get in and get my parts out. But these are all just duplicates of what we've seen already. Actual values, you can't program anything on here. This will just show you what's actually going on with the machine as you're operating it. And if you go into the second page on the time, when you're running in automatic mode, this will show you the actual parameters, the actual times that it's taking to do the injection, to do the dosing, what the actual time is, and then the overall cycle time. The idle time is generally me taking parts out of the mould, but this gives you an idea of how fast the system is going, and obviously if you need to go a bit quicker, you fiddle with the settings and try and speed things up. And then on the other control panel you've got conveyor belt, which I don't actually use, and you can set, when you are using it, you can set it to run continuously or to switch on every cycle for a certain period of time. These settings you do need to set, but I don't use them. So in a production environment you might have the conveyor switch on after every 10 cycles for a few seconds just to move the parts out of the way, but they're not important for what I'm doing. The safety guards, again, I don't need to mess with those, but I do need to put it in semi-automatic mode, which is where the machine will open, stop, then I get in and remove the parts. I then press play and it will continue. If you have that set to no and you switch it into the automatic mode, it will just keep doing the complete cycle. So if you've got an ejecting system, then you set that to no and the whole thing runs itself, theoretically overnight, lights out. And here we've got various alarm programs, error evaluation and so on, number of errors. Some of these values you need to set to 1, but this is just counting up how many cycles didn't work, and you can set various other parameters here. Cleaning cycles, does it purge after it's finished doing all of its moulding work. Alarm messages, a few issues. This is telling me that there's a value I haven't yet programmed yet, and the oil temperature, I haven't set that either, so that's flagging an error. This is the cassette program, where you can save stuff to the tape and erase the tape and so on. I don't tend to use that very much. Over here we've got pressure measuring systems which can be built into moulds. I don't use those. Over here, mould heating systems, which again I don't use, but you do have to set these parameter set numbers, and these parameter sets, basically you can have multiple programs in the machine and switch between one program and the other rather than saving them onto tape. So you tell it which of the programs you wish to use. This is all the valves, and there are pages and pages and pages of valves, and these are all of the settings and the various inputs that the machine is reading. So there's a lot of information there. None of these are settable, these are just so that you can see if there's any errors. This is the host processor and order page, and that's the only one you really need to program, the position of material changer, because it only accepts parameters 1 to 4. And this is quite useful at times. If you were doing a job where you wanted, say, 1,000 mouldings, you can set the pre-select counter, which is how many parts you want to mould. It will then count up how many parts you have moulded, incrementing that every time you do a cycle, whether it's in fully automatic or semi-automatic. It won't do it in manual mode, and this is obviously tied into the number of cavities that you've programmed. If there are any problems, it will count up the bad parts, and it will tell you how long you've got left until your order is finished. So in a production environment, this screen gives you quite a lot of control over what you want it to do when it's reached its limit, and you can then tell it to cool the system down and switch off after a certain amount of time. So these are fully programmable machines designed really for lights out production. And then the only other screen that's really important is the cooling system. So cooling downtime isn't really important. This is the oil temperature, which is currently showing 12 degrees. That needs to be set to at least 30, as you can see here, between 30 and 55. The machine will not run in automatic mode until the oil is up to 30 degrees. So that's the minimum that you can set. You can run it in manual mode, and then there is a temperature setting here for the feed yoke, which isn't too critical. And then down here, these are the cooling lines that go into the mould. There are quite a few of these. As you can see, there's another page full of them, and even more. So there's a lot of cooling, automatic cooling that the system can do, and you can either read off thermocouple settings or just set percentages to whatever you want. So I don't tend to use cooling systems on this, but there is a manifold around the back of the machine which ties into these, and I don't have thermocouples on it, but I can regulate the valves on the back of that cooling manifold to put water through the mould to try and keep it cool. Over here, I want the cooling to be on permanently. You can set it to be on just at specific times. And then over here, I go down, you just need to set these to various tolerances. So again, the machine will basically flag an error if it's not within these parameters. And that is pretty much it. There are some other miscellaneous controls here for automatic on-off stuff. These are all the machine data pages, various programming pages, handling devices, parallel operation, special programs, print. You can actually print stuff out here, and there is a way on this, which I've never quite figured out how to make it do, but there is a way of getting it to generate graphs which show you the actual pressures and settings that the machine is operating on. So that's quite a useful feature, but I've never actually figured out how to make that bit work. So that's a quick rundown of all of the settings, and although it seems quite daunting, it's basically mould opening and closing, the nozzle assembly, the dosing, the injecting, the holding pressure which comes after the injection phase. There's all the temperatures that you set for the barrel to heat your plastic up, the times which are duplicated, the ejector system that you don't use, the actual values which are kind of useful to keep an eye on what's going on, and the operating data, which you override these settings anyway. So it seems like a lot when you first switch these machines on, but once you get the hang of them, you can program all of these settings in a matter of minutes, and obviously you've got an enormous amount of control over them for different jobs that you might be running.